Before a language model reads a single word you type, it chops your text into pieces you've probably never thought about. When you send a message to an AI, the model doesn't see letters or words the way you do. It sees numbers, long lists of numbers. And the step that turns your text into those numbers is called tokenization. A token is just a chunk of text. Sometimes it's a whole word. Sometimes it's part of a word. Sometimes it's a single punctuation mark, or even a space. Take the word unbelievable. A tokenizer might split that into un, believe, and able. 3 separate tokens. It depends entirely on which chunks the model was trained to recognize. The way those chunks get decided comes from a process called byte pair encoding, or BPE. It starts by looking at a huge pile of training text and finding which pairs of characters appear together most often, then merging them into one token. It keeps merging the most common pairs, over and over, until it has a fixed vocabulary, usually somewhere between 30,000 and 100,000 tokens. Common words like the or is end up as single tokens. Rare words get broken into smaller pieces. Each token in that vocabulary gets assigned a unique ID number. So when you type your prompt, the tokenizer looks up every chunk in the vocabulary table and swaps it for its number. That list of numbers is what actually enters the model. This matters more than it sounds. The model has a limit on how many tokens it can handle at once. That's what people mean by context window. A longer prompt uses more tokens, and once you hit the limit, earlier parts of the conversation can get cut off. Tokenization also explains some genuinely weird AI behavior. Ask a model to count the letters in a word, and it sometimes gets it wrong, because it never saw the individual letters, only the token. It's working with chunks, not characters. Languages that use non-Latin scripts, Arabic, Chinese, Hindi, often need more tokens to say the same thing as English. That can quietly affect how much of a conversation fits in the context window, depending on what language you're writing in. Numbers are another quirk. The number 472 might be one token, but 4729 might be split into 2. That inconsistency is part of why arithmetic can trip up language models. The numbers aren't stored the way a calculator would store them. None of this is a flaw exactly. It's a practical trade-off. A fixed vocabulary of tokens makes it possible to train these models at scale. But it does mean the model's relationship with text is genuinely different from yours. So the next time an AI gives you a strange answer, it's worth asking, did the tokenizer shape this? The model never saw your prompt the way you wrote it. It saw a sequence of numbered chunks, and everything followed from there. If you want to see this yourself, most AI labs publish tokenizer tools you can paste text into and watch it split in real time. It's a small thing that changes how you think about every prompt you write.